All right, thanks, Ted and Kirill and other organizers for having me. It's great to be here. So we're going to talk about ngrx store. But before I get into that, absolutely unrelated question to you guys. How many of you like the Minions movie? Minions? Yeah? Good. So I'm going to use some references, and I won't feel guilty of using it then. All right, so my name is Pavan Podila, and I've been doing UI development for close to 15 years now. Started on Java, .NET, moved on to iOS, Mac, and now I'm doing a lot of web. I love the web platform. And I work at this company called Sapient, and we are a huge financial consultancy. We spend a lot of time building large-scale financial applications for some of the big names on Wall Street. Some of those people from those big names are actually here. So we solve some really interesting and challenging problems. So if you'd like to learn more, please see me after. Or check out Sapient at sapientglobalmarkets.com. All right, so how many of you heard of Redux? You heard of this Redux? All right, maybe not this Redux, right? So people have been going crazy about Redux for quite some time now. And if you open up internet or open up Twitter, you'll see definitely some mentions of Redux during the day. And if you go to UI circles, you'll see them mention Redux at least 5 times in the same day, right? So Redux is very popular. And, but not all of us may have used it. And some of you maybe today have used it from maybe the React side, and, or some may have just heard of it right now. So, but for the benefit of everyone, I'm going to get on the same page so we can all understand what Redux is from the ground up. So it all starts with a single equation called UI is a function of state. What this really means is that you have some data, and you want a visual representation of the data on the screen. And there is some transformation function, the fn over there, which is doing this magic for you, taking the data and putting it on the screen, right? So given the same data, you should always spit out the same UI, technically. But of course, in reality, it never happens. We screw up in different ways. But that aside, the idea is that you have a single equation, which is the groundbreaking equation of UI development. May not be as important as the relativity equation, but still pretty important. Right? So if you forget everything else in this talk, at least remember this one. UI is a function of state. And there is some transformation that happens which takes your data and creates a UI out of it. So what that really means is that this transformation takes the data and creates your views and components in case of frameworks like React or Angular. And what we'll see now is how we actually do this transformation. Right? There's a lot of interesting processes going on internally, which takes plain data and then spits out UI. Now, there's an interesting side effect of this equation. If you look at the timeline of your application, over a period of time, what you'll see is that it spits out states. And for every corresponding state, you will have a UI generated for you on the screen. Right? This transformation function that is happening from state to view is doing something magical, which will actually create the view for you given the same state. It'll always create the same view for you given the same state. So that's the interesting side effect of actually having this equation. Now, how does this transformation actually happen? And this is where the Flux architecture, if you heard of it, comes into being. Originally proposed by Facebook, what Flux really says is that you have some standard actors in your entire story. You have a view which fires actions, and you have stores, multiple stores sometimes, and you have a dispatcher. Now, the views always talk to the stores through a message passing system called the actions. So views fire actions, and then store notifies when there is a new state. And there's someone in between called the dispatcher, which actually takes in the actions and spreads it across to all the stores that you have. The reason why you need a dispatcher is because you have multiple stores. Right? I mean, the standard classic Flux architecture requires you to have multiple stores. And you have some kind of a coordination going on between these stores, which is why you need something called a dispatcher. Right? The dispatcher basically takes the responsibility of distributing the actions to all the stores, making sure only the store processes things when some other stores has finished certain things, so on and so forth. But there is a dispatcher in between. What if we only have one store instead of many stores? Right? So if you have only one store, you probably don't even need a dispatcher. Right? Then you can just fire the action straight up to the store itself. And that's exactly what happens when you simplify this whole equation and the flow itself. Views will simply fire the actions directly on the store, and the store notifies whenever there is a new state. And you can see there is a cycle going on over here. And that's why people call it a unidirectional flow, because the direction is always one way. Views always talk to the store through an action, never directly. And the actions are the one which result in some mutation happening inside your store, which results in new state. And then finally, that gets generated and notified to the view, which spits out a new UI for you. So If you look at apply the same ideas to Angular now, instead of a view, we have two more components, a component and a service, which can actually fire these actions. And both of these actions will be fired onto your store, right? Because these components never talk directly. They only talk through message passing systems like firing an action. And when the store changes and mutates and creates a new version of itself, it notifies the state to the component, which re-renders itself. Clear? Right? The flow is very simple now. You always talk in actions. We never talk directly. Views fire actions. Actions modify store. Store notifies the view, and then it re-renders itself. Really simple. And really simplified version of your Redux now going on over here. So far we have seen what the flow looks like, right? It's always in one way, and there's this action passing that is happening between the views and the stores. Let's see what actually happens inside the store. It's been like a mystery box over here, where the store is doing some mutation, but what exactly is it doing it? How is it doing it? And so on and so forth. So let's kind of open up the store a little bit. What the store takes as input is a current state and an action, obviously, right? And it uses these two inputs to generate a new state. And it goes through a series of reducer minions, right? Not those minions, but they could still technically do the job because minions can do anything. But stores can actually use the reducers to do all the job. So when you get in the action inside the store, these actions are actually sent out and farmed out to a hierarchy of reducers. Now, the reason why you need a hierarchy of reducers is because your app state could be pretty big, right? So you break it down into small functional areas, feature areas, and then you can assign a reducer to each of those feature areas to do them the job of creating a new state. And then you roll up, aggregate the state across all your application's features, and go to the top reducer, which then produces the new state. So you need this hierarchy in between to kind of build up the new state for you. And the reducers take responsibility of creating this new state. So his question was, is there any guidelines for actually designing the reducer tree? And the standard guideline I would probably use is that you divide it by functional areas. Right? I will take an example also how I do it in the demo. But let's take a simple example. Let's say you are showing an album of photos. Your album itself could be a functional area. You could have a dashboard that presents all the albums. You could have a single album, or you could have photos inside the albums. So you have a lot of hierarchy already over there. Right? Dashboard contains albums, albums contains photos, and so on and so forth. And if there's a lot of interaction logic happening at the photo level, you don't want that to be taken care of at the dashboard level. Right? You probably want a small reducer over there which just handles the photos and then rolls it up into albums, albums into dashboard, producing the new state for the application. Right? So basically think in functional feature areas, and I think you should be good. But if you're still not clear, meet me after and we can discuss about your specific problem. OK, so what does a reducer really look like? It's just a simple function. It's actually a pure function that takes in the current state and the action that the views and components and services have fired. It looks at the action type and then creates a new state. That's about it. 1, 2, and 3. Taking the state in action, look at your action type, create the new state, and that's about it. That's what a reducer actually does. So with this, we have all the background knowledge we need to look at ngrx store, which is the Angular version of Redux. So the best part is everything stays the same. Whatever we talked about so far, there is still an action being fired on the store, and store produces a new state. So what's happening is the stuff in between, which is on the store itself. And that's where you have RxJS. RxJS is a library for doing stream-based processing. And what I really mean with that is that you can think of your data as a stream of continuously producing values. And you can actually combine streams, you can mutate streams, you can transform them and create new streams, and so on and so forth. It's a different style of programming, but it actually allows you to do more with your data by using RxJS. So the store itself effectively becomes an observable now, because everyone is observing the store, right? The UI is simply an observer of the store. When the store notifies, the UI is going to render itself. So it's a pure observer. In fact, we can actually build applications without even having UIs. And I keep telling this, whenever whoever is working with me every day, that imagine you didn't have a UI to deal with. You just had a command line, and you could still build everything with a store and a reducer-like structure. Because then you can actually simplify actions and see how the store changes, and now you have all the data you need to show your new UI. So it's all about just simply knowing how the state is changing on the store itself. So this brings us some interesting side effects now. You can actually visualize your application as something being a snapshots over a period of time. And as new snapshots get produced, the new views are also continuously being produced for you. And through the power of RxJS, you have a stream which actually gets notified which notifies you whenever there is a new state produced onto the application stream. And then you can subscribe to it, and then you get notified, and you just re-render yourself. So this is the overall flow now with ngrx. Everything is pretty much the same, except the part where the store becomes an observable. So components and services fire actions on your store. The store takes in the previous state and the current state and your action, goes through some mutation through your reducer minions, rolls up and creates a new state, and gives a new state as a notification on the application stream. This is a really important movie going on over here. So once you have the new state, the component's job is to simply re-render the state, right? Fairly simple. Any complexity over here, by the way? Sorry, didn't mean to pick on you. So it's time we can actually look at some code. Right? We all love code, and minions love code too. So let's look at that. So in 4 slides, I'm going to show you the entire ngrx structure. Right? Irrespective of how big of an application you build with ngrx, this is probably the only set of activities you'll ever be doing. The first step is to actually inject your store, and you do that inside your app module. So you create your store module, provide the root reducer, which is going to actually transform your entire application state over a period of time, and then that's what you put in your app module. Right? Next step is to actually inject it. Because we have this power of dependency injections, you can actually inject your stores inside your components and services. So here's an example where I'm creating a photo component, and I'm just injecting the store with app state as my generic type, because that's the type of my entire application state. And then what I'm going to do is inject it again, but this time I can use it to fire actions, right? Because that's the job of components and services. They can actually fire actions onto the store. And you simply do that by store.dispatch, passing in the type parameter, and then you have your action fired onto the store. The store, of course, mutates itself, creates a new store, which is why you need to subscribe to it. And you create subscriptions inside your components by looking at your store, which you already injected in your constructor. You pick a piece of the state that you want to render. So your app state is what's being sent to you inside your store, right? So you just want to pick a small piece that you want to render inside your components. So you apply a mapping operator like a select or map and transform, filter, do whatever you want over there. And then that's the piece of state that you want to render. And then you subscribe to it, and then that's what you use inside your templates. Right? So that's the only set of things you'll ever be doing. In fact, even if you build large-scale components, most of the time you're probably spending a lot of time in defining what needs to be extracted out from your stream and then rendered onto your templates. Let's actually see some of this in action. So we'll take a very simple use case over here. And I'm already running Webpack in the background, not Angular CLI. Sorry, John. But eventually I will. So let's take a very simple example. Right? We'll start off by creating the store module. And the store module is being injected from your ngrx store. Right? You guys can all see it? OK. Right? So the first step is to actually inject your store module inside your app module and provide the root reducer. And a root reducer actually is going to reduce the entire application state for you. And instead of creating one giant reducer that does everything for the world, you can actually break it down into smaller reducers. So that's what I've done over here. So you have your reducer, and then you can have your state broken up into 2 parts, the album and the operation. And album is managed by the albums reducer. Operation is managed by the operation reducer. Albums is simply giving you the state of all the albums in your app. And then operation is where you're storing the state of your application, whether I'm loading something or something like that. So before we go deeper into the code, let me just give you a quick demo of what the app actually looks like. So here you have the app. I'm simply showing you a list of albums. You can go into an album and see all of the photos. You can actually change the album itself. Save it, and this fires an action, and we'll see what happens in the flow by walking through the code itself. So now if you go back, you have your album showing you the new name. You can dive deeper into the album itself to see the photos and so on. You can change it, and you can go back, and now you have your name changed over here as well. So it's a fairly simple app, nothing too complex. Just want to show you that you can actually use actions to do all of these things. So how does the flow actually look like now? So let's take a simple example where I'm loading the application. So when you load the application, notice that you will see this loading indicator for a short time, and then you load the entire set of albums. Right? So how does that work? Let's take that and walk through the use case for that. So it all starts in the shell component. And what I'm really doing is loading the albums when I init the shell component. Inside load albums is where I'm firing the first action to start loading the albums. So when I fire the action, someone is actually listening to the fact that there is now an operation called starting of album load or something of that sort. So this is actually being used inside my shell component. So let's see over here. I think it's in the dashboard, sorry. So the dashboard actually shows you the loading if the loading is true. And inside dashboard component, you have actually subscribed to the store itself. So here is where you're selecting the albums and you have a subscription to the load. And when you subscribe to it, you get your loading flag, which you set on your component, and simply use that to render your template. So anytime now the loading property changes, it's going to re-render the template with loading. And loading will be true the first time when you load it. Once the albums have been loaded, it becomes false, and then you don't see the loading message anymore. So that's what's happening over here. It simply shows the loading first, and then it goes away, and the loading state is gone. So the way it's working is through a reducer now. So when you fire the actions are first going to your reducer, so which is the operation reducer. Let's look at the loading first now. So inside your shell service, sorry, it's over here. In your load albums, you're first firing the action for starting the album load. And then once you have the albums, you're firing a dispatch for loading of the albums and then loading the end of the album load itself. So basically, you have a three-state process over here: start, load it, and then end it, right? So you have your reducers also pretty much reacting to all these actions. So let's take a look at the photos reducer, sorry, the app operation reducer. So operation is where I'm actually storing the state of the load flag. So when I load the albums, I'm going to simply set this state to loading albums to true. And in the end, I'm going to make it false. Right? That's what I'm doing over here. And by tracking these actions, we know all the sort of activities that's ever happening inside your application. So here is the actions that are being handled by this reducer. Similarly, you also have the albums reducer, which is loading all the albums. So when the albums get loaded, it actually sets the collection, creates a new state. Notice that it's creating a new state. It's not simply mutating the existing state. There are other libraries which you can use to kind of create an immutable data structure. But here we're doing something very simple. So you create a new state, set the collection, and then you can set the other things to null. Because when you start out, you don't have any selections. When you have a selection, you set the selected album. When you have a selected photo, you have the selected photo set over here. That's what's happening when you navigate into an album and into a photo. You're setting the selected album and the selected photo. And the component is simply just showing you the details of the photo. All right. So now, if you have a large application, right, and I'm sure you'll start off small and eventually become really big, you want tools to kind of help you out deal with this large application. And luckily, we have a tool built right into ngrx. It's actually a separate module, but it's called Store Dev Tools. So let me just pull that up. This map module. All right. So with this, we can actually see what all actions are being fired on your application. All right. Load. All right. So here you can see that this is the standard Redux dev tools, actually. It was originally created for React. But just because ngrx works exactly the same way internally, those same tools can be used for ngrx. No extra work, which is great for community reuse. Right? Software has to be reused. This is an example of it. So what you're seeing over here is all the actions that have been fired so far. I have started the photo load. I have loaded the albums because I have to load the albums before I load my photo. And then I'll end the album load, select the photo, and then end photo load. Right? You can actually walk through all these states. Imagine I told you, right, you have a stream of application states. You can actually walk through this step by step now. All right, so right now over here, you go to the next step, you're loading. You go to the next step again, you load the albums. Oops, I'm actually clicking on the wrong button. You load the albums, then you load the photo, selected the photo, and then you ended the photo load. So you can actually walk through the actions that have happened on your store. And if you have a really large application, you can break it down, and you can actually see what's going on at any time. And then you can even fire interesting things on the store itself. So here, I'm going to fire an action. So let's say the start photo load. right? I should be able to do any action at any time. If I fire this action, I should be seeing a loading indicator. Cool, right? So you just fired an action, and the store automatically reacted. The component was notified that the loading property has changed. It just shows that on the screen now. But the UI is a function of state, so we're just seeing that in action now. If I fire an end photo load, that thing should just go away, and it does. So it's a very simple way to control actually what gets shown on the UI. As long as we have a series of actions being transmitted, mutating the store and putting it into a new state, the UI is just a visual representation of that. At any point in time, your UI is simply showing what the data contains and what the structure looks like, what the relationships look like, and what kind of stuff you can do with it. When you have such kind of a system set up, it's very easy to reason about your applications, no matter how big they are, right? Because you're breaking them down into smaller functional areas. Within those functional areas, you have reducers actually building up the new state. And through the power of actions and creating the new state, you know how the data is actually flowing inside your application. And I think that's a very nice way to reason about things, especially for really large applications, because you don't have to worry about what direction data is flowing. It's always one-way traffic and never get hit by others. All right, so that's about it. Now, as I mentioned, this is a Chrome extension, so I'm going to give you the links in the next slide. And you can also see it when the slides are uploaded. But in addition to the store itself and the dev tools, there's also one more little project, side project of ngrx called ngrx effects. And this actually banks on an idea from the React world called sagas. And what it really means is that you can actually think of not just your states as an application, a stream of states, but also actions that are being fired on your application as a stream of actions. Once you have that set up, you can actually work on your actions and mutate the actions, take action itself on the action, do something, and then fire more actions. So here's an example where you're doing a login action, and they call it effects. So you can create an effect where anytime a login action is seen on my store, I'm going to go ahead and then fire off an authentication request. And then I'm going to switch map, which is an RxJS operator to simply change the stream data content, and then fire off an action called login success. And then after I have a login success, if for some reason the authentication fails, I fire a login failed action, right? So you start with your login start or login, and then you can either go into login success or login fail. So you have a simple state tree over here, and with that, you can actually capture all of those things in one place instead of doing it inside a reducer. So there are different ways to kind of solve these problems now, and as the application becomes larger, you probably want to investigate into things like this to kind of reason about things, and also to kind of contain the complexity that's growing inside your application. So that's about ngrx effects. Let's get back to this one. All right, so that's all. So these are all the different links you can look at to learn a little more. Of course, I haven't given you everything about ngrx, but this is enough to kind of get you started. And thank you very much. Yeah.